Let's now discuss about the physical properties of fatty acids. So it is said right here that the physical properties of fatty acids and the lipids that contain them are largely determined by the length and degree of unsaturation of the fatty acid carbon chain. Subot pa sabot, ang physical properties daw of fatty acids depend on the length, ang katasun sa iyang chain, which is determined by the number of carbon atoms present in the chain, and the degree of unsaturation, meaning pila ka buok double bonds present within the fatty acid carbon chain. So when it comes to water solubility is a direct function of carbon chain length. Okay? Direct function of carbon chain length, wherein, okay, let me just go back to that one. Okay, so water solubility is a direct function of carbon chain length, wherein solubility decreases as carbon chain length increases. So take note of that one. Solubility decreases as carbon chain length increases. So meaning, the longer the chain, the lesser its solubility. Mas taas ang chain of fatty acid, mas gamay or the lesser is its solubility in water. Which is why it is said here nga water solubility daw is a direct function of carbon chain length. Okay, so remember that one. As length increases, solubility decreases. Which is why short chain fatty acids have some solubility or have slight solubility in water, whereas long chain fatty acids are completely insoluble in water. Now, the slight solubility of short chain fatty acids is because of the presence of the carboxyl group within the structure. So if you can recall earlier, I have told you fatty acids have carboxyl group, right? The carboxyl end. Now, this carboxyl group is polar, okay? Now, because of this polar hydroxyl group, short chain fatty acids have slight solubility in water. Now, in the case of long chain fatty acids, although nga naa gihapon siya carboxyl group or carboxyl end, its long non-polar component would completely dominate the action of the polar carboxyl end. Okay, so remember that one. In short chain fatty acids, it is still slightly soluble in water because of the presence of the carboxyl group or the carboxyl end. Now, although long chain fatty acids also has carboxyl groups, its long nonpolar chain would completely dominate the action of the carboxyl group, which is why it is not soluble, completely not soluble in water and other polar solvents. Moving on, the second property of fatty acids is on melting points. Now, the melting points is depending on these two, okay? The length of the carbon chain and the degree of saturation. So remember this one. Ang melting point daw would depend on the length of the carbon chain and the degree of saturation. The degree of saturation is just the number of double bonds present in the structure. Now, if we take a look at this illustration right here, this one, this graph, we have here on the um, the y-axis is the temperature, whereas on the x-axis is the number of carbon atoms. So we can see from here nga saturated fatty acids have higher melting points than unsaturated fatty acids. So these three, kaning tulo, oleic acid, linolenic acid, and linoleic acid are all unsaturated. Whereas this one, stearic acid, is saturated. Now, makita nato di ani sa graph na saturated fatty acids have higher melting points than unsaturated fatty acids. Furthermore, in the case of saturated fatty acid, in saturated fatty acids, the longer the chain, the higher its melting point. Okay? So lantawan ninyo diani sa atong saturated fatty acids. Mas taas daw kuno ang chain, okay, as indicated by this green line here, the longer the chain, the higher its melting point. Now, going to these three unsaturated fatty acids right here, the higher the degree of unsaturation, meaning the more number of double bonds, the lesser its melting point is. Okay? So again, in the case of unsaturated fatty acids, mas daghan ang double bonds, mas gamay ang iyahang melting points. Okay. So always remember that one. Generally, again, saturated fatty acids have higher melting points than unsaturated fatty acids. Now, for saturated fatty acids, the longer the chain, the higher its melting point. For unsaturated fatty acids, the higher the degree of unsaturation, meaning the more double bonds, the lesser is its melting point.